Alrighty, another weekly update. I was actually supposed to put one last week, but I had some issues uploading it. Not sure what's going on with YouTube and my phone, but anyways, bi-weekly updates. But yeah, I don't exactly remember what I was supposed to say in that other video, so I might be repeating some stuff. But anyways, I guess let's start off with the worst of the worst is my XRF machine. So my XRF machine is gone. It is being sent back to Rigaku. Actually, not being sent back. It's already back at Rigaku for service. So apparently they're saying that the X-ray tube is failing. They already changed it out. Seems like it's fixing the problem. I'm gonna go too much into detail, but pretty much it was causing some issues. I was doing a measurement, saying platinum. Next week I was doing the same measurement. Wasn't showing platinum anymore. Though to be fair, it was in very, very, very trace amounts. So but you know, for me that's important. So anyways, hopefully get that back soon. Really need that. But anyways, let's move forward to this big mama. All right, so this is my wavelength dispersive XRF. I got some trays just done for it. I'm not sure how much you guys know, but I already got the X-ray powered up, all got it running, got it connected to the computer, all that stuff, all the gizmos. Got a water ion remover thingy mabob, so it's very clean water for the X-ray. These trays, I was originally going to purchase it from Rigaku, but they had like a 3-month lead time, so I wasn't going to wait till next year for them. And also they're like $1,000 for each tray. I need 4 of them, plus sample holders, like $500 each. I need a lot of sample holders. As you see, each one needs its own sample holder. So I got the trays done. What I was able to do is I told the computer, hey, go to this position right here or this position. And then once I went there and started going down, open the door, that activates the safety measure, turns it off, the moving device, put a marker on the railings, then told it to go to close the door, let it go home, told, okay, go to this position. Did the same thing, marked it, and then with a micrometer, I measured the difference. I was able to find out that it's exactly 75 millimeters because engineers like to not be at like 72.367. Nobody does that typically. So anyways, yeah, I was able to get that dimensions pretty well. I brought over my 3D printer, so got to print out the sample holders. I already got a schematic I found on the manual of a cutout sheet of what the sample holder, and based off that, I think I'm able to reverse engineer the sample holder. So pretty excited about that. But anyways, as you see, we got a lot more done. We got this table installed. We got another table island installed. We got so much more. Still a mess. I literally just finished installing this table today. I have a lot of tools here that I'm going to start getting out. I don't need a lot of these tools anymore because I finally am done with most of the cabinets. I still need to finish hooking up the sinks and stuff. So, you know, still need a bit of tools. And also I just used a lot of these tools during manufacturing. Like this sanding machine, I actually use it specifically for my electrolysis cell. There's one part that I need to sand down, and it's very great for that. So but yeah, that's going to be one of my goals this week, is try to clear this all out, clear everything up, you know, try to get that done. So yeah, let's see, we got that X-ray done. Oh, the refining cell. So refining cell, the original design I had where I was just doing direct electrolysis and I had a polyester membrane, or not really, it's not a membrane, it's just to make sure when stuff falls it doesn't go into the chamber. Not gonna work out, sadly. So that's a very disappointing. Hey, good for me because I'm able to sell my special ion exchange membranes instead of that. You know, but whatever. I mean, you know, my goal was, you know, I'm still open sourcing all this technology, but the ion exchange membranes, we're gonna open source that a bit later. So meantime, you guys are able to buy NAFI and a couple other stuff as an alternative to the ion exchange membrane, so if you choose not to use ours. But anyways, so yeah, this new, not really new, but new quote-unquote refining cell actually is based off the same exact principle as my leaching cell. This one though, I have an acetic and nitric acid solution, and what's going on pretty much this is the positive side. It pumps through, gets pumped through into this little chamber right here. In this chamber I have lead, mostly lead or mostly iron, and also like vanadium. But point is, what this thing does is you have bars here, right, with mostly base metals and a very small amount of precious metals. It'll dissolve all the base metals, plate them off onto the negative electrode, and pretty much separate the base metals from the precious metals. So with this solution, it won't work for palladium and silver though. If you have any palladium or silver in your bars, it'll dissolve into acetic and nitric acid. So that's a bit of a downside, but it's absolutely wonderful. Those bars, I originally tried dissolving them in nitric acid, and we were doing boiling nitric acid for literally days, and it barely affected the bars. The vanadium in there, I think, was just such a pain. So this proof of concept is a huge big deal, because you're able to put any sort of base metal, 30 bars in there, remove all the base metals, all that junk, all that garbage, and turn it into a concentrate, which most refiners will be much willing to purchase, right? So a lot of refiners that require a purity of like 80 or 90% of higher in order to purchase from you, this solves that problem and allows you, without using expensive chemicals, expensive complicating steps and this you just put bars in there, out, you get a concentrate. Very easy, very simple to work with. So I'm gonna, like I said, we're still optimizing that. I'm waiting for XRF so I could do some final analysis, and hopefully that'll be one of our first products we'll be selling. So fingers crossed. But anyways, we got that. I'm producing more electrolysis cells. I already got them cut up and stuff. So I'm doing some experiments with my membrane. Fabricating our special ion exchange membrane. So again, hopefully we can get big progress on that, and hopefully we can actually come up with a product that people are actually able to purchase, use, that you just, like I said, either you're able to leach, or with it, because same sort of unit it can be used for both, either leaching or let's say, or scrap metal or scrap e-waste out of PGMs, or it can be used to refine it. So I actually see it symbiotically, because my leaching solution, or my leaching electrolysis system, will also plate off base metals, and that's one of the major reasons why I developed this system, is because I was having problems with, pretty much I have this concentrate solution of heavy metals, and how do I remove all the gunk out of it and leave behind the precious metals, so then I can do further refining to separate out each individual one. And that's how we came up with this system. So pretty excited, pretty happy. Like I said, some pretty big things are happening this week. Probably is going to be, this upcoming week is going to be a slow week. I have some personal stuff in my life, so I'm gonna focus on that. Can't be working 24/7, but yeah, I'm pretty excited for this. I'm trying to think what else. I have something else. Probably have something else. Anyways, if I do, I do. If not, I not. But yeah, thank you for watching. Again, please subscribe, and please, if you're interested, if you're a company, if you have material you want to process, reach out to me. I might be able to help out. We have a couple companies right now we're actually working with, and we're showing them some really amazing results. They're very happy, and we're moving forward on that. But and again, if you're watching this and you find this technology amazing and innovating, one thing I recently not discovered, but I refound again. So after we leach the ore, the toxic heavy metal ore, or even just sand, that barren sand, we'll leave that bucket outside, and algae will start growing. It absolutely fantastic. So beautiful seeing how my technology turns toxic barren rocks and sand into fertilizer rich, life just enriching material that you can use in the garden. A lot of and I'll make a different video about this explaining, but yeah, it's very beautiful to see. But again, if you want to help out, like this machine, I still need to buy a lot more calibration sets. I need to buy a vacuum pump for it. That's going to be probably another $5,000-$10,000 just to get this machine running. If I can get it running, then that's a huge deal, because that has parts per billion accuracy. So everything here costs money. I want to put ceilings up, right? There's a lot of things I need to do to finish this workshop, and it all costs money. So again, please, if you want to help out, if you want to fund this project, and help this turn into actual product, please reach out to me. It's irowow@gmail.com. So again, thank you for watching. Stay subscribed, and I'll keep you guys updated.